Okay, let us start the session. Actually, today is the week 12 assignment discussion, and I think this is the last week of the course control engineering. Okay, just please someone confirm that my screen is visible properly.
Yes,
Okay, so thank you so much. So let us start. Okay, and the week 12. The last week actually we have discussed related to state space model. Okay, how to represent a plant using this system like a time varying system, how it can be represented. Okay, so this time actually this week 12 is related to little bit advanced of the uh, week 11, like we have to go a little bit further related to state space model. Okay, so before that, I think I hope everyone actually you have completed the week 12 course items, okay, that will be uploaded in the portal. Okay, so let us go to the first question. Okay, so try to read this question. Just I'm going to solve a little bit 7 8 questions today because I have also leave early because I have some meeting. So let's see how much you can complete. Okay, so okay, this is a common data question, question number 1 2 3. Okay, so try to read the question and try to solve what is it asking. Okay, I have not written the questions here. I'll write what are the questions here, but try to understand that what is the system, because this question I have taken actually whenever I was appearing in detailed exam of control engineering. Okay, I think 4 5 years back. Okay, uh, uh, okay, we just take read the question that this is a system that is given a pendulum, okay, on a cart. Okay, so now this is the non-linear dynamic equation he has given. Okay, these are the two equations. Okay, so now based on these two equations we have to model the state space model of this one. Okay, so he has given the cart of the mass is capital M and cap, and the pendulum has a mass of small m. Okay, 1 and m equal to 10 they have mentioned. Okay, and the length of the wire that pendulum is tied, the inverted pendulum structure, you can say the this is 1, and g equal to 10. Okay, the frictional coefficient part. So now what you need to do, this is a non-linear dynamic system. Suppose a system is coming like that, then how you have to model the state space model. But before doing that, he is also asking that after you have done that, you have to linearize the system. Okay, about the vertical line theta equal to 0 and theta dot equal to 0. These are the two equilibrium position he has given. Okay, so one equilibrium position, this is equal to theta equal to 0. Okay, so another one is theta dot equal to 0. What is theta dot, we'll see now. Okay, so we have to this is a non-linear system. So in this non-linear system dynamics we have to linearize it. Okay, so how to do that? So first of all, what you need to do, you just write the basic equations. Okay, what are the equation that he has given us? Just let me write down for you. Okay, on the right hand side I'm just writing out. You can also simultaneously write on with me. So the two equation what he has given, one is m plus m, x and double dot. Okay, double dot means x is a state vector now. X is nothing but the displacement, so we are taking the displacement as a state vector. Okay, then x double dot he has given, next small m and l, and theta double dot. Okay, theta is the angular position of the pendulum from the initial equilibrium position. So you have to take the second derivative of that, and you have to multiply cos theta plus ml theta again dot, and you have to take the square, and you have to multiply sine theta, and this is equal to the applied force. Okay, this is the only force which is applied outside. Okay, you can say this is the input of the system. Okay, like that. So second equation what he has given, l theta double dot minus g sine theta minus x dot cos theta equal to 0. These are the two equation he has given. So how to model the system? So what you need to do, you first, what is the state vector to identify? The state vector is the displacement x. So this is the state vector. Now in this state vector, another state vector you need to identify. So there are two state vector x and theta, okay, from these two equation, because other are constant and f is the input of the system. So what you need to do, you just write down x. How we represent that? In the last class, I told you that differential equation how you represent in the state vector. So what you need to do, you write x equal to x1. Okay, this is the first thing you can do. Okay, if x equal to x1, then how can you represent x dot? This x dot is the differential of the state vector. You represent another variable. Let's say I am doing x2. Okay, then you have to represent theta. Theta is, let's say I am taking another variable x3, then theta dot I am representing another variable, let's say x4. These are the four things you need to do first. Because why? Because in this question he has given that x dot, theta and theta dot be the state variable in that order. Okay. So now what you need to do, once you have written this, now whatever the equation you have written on the top, you put all these values there and try to simplify this. So what you need to, I'm just writing here m plus m, okay, x2 dot, it will be x2 dot, okay, because if x double derivative is nothing but, if I can write here, x double derivative is nothing but x2 derivative, take both the side derivative of this one, okay, so that will be x2 double, okay, x2 dot minus ml, similarly you can write here x4 dot, okay, theta double dot is nothing but, if write on theta double dot, that will be x4 dot, okay, just take another derivative of theta, like that ml x4 dot you can write, then you write down cos x3, okay, then ml x4, okay, and letting x4 is theta dot, and you have to write the square of that, okay, then you have to write sine theta, and this is equal to your f. Let's, as you give a equation name, this is equation number 1, okay. After doing the first equation like that, then you have to do simplify this one also. Second equation on the top, what is given in the question, nonlinear equation, L into theta double dot. Theta double dot is nothing but your x4 dot minus g sine theta. Okay, there's no change here. Then x double dot cos theta. X double dot nothing but your x2 star and cos. Okay, also here you can replace this theta. Theta it can be replaced by x3, so you can write also x3 here. Cos x3 is equal to 0. This is equation number 2. Once you have written down equation number 1 and equation number 2, okay, then after you have written down equation number 1 and equation number 2, then give me further simplify this equation, okay. Let me copy actually these two. Let's, sorry, one more time. Okay, just copy this part. One second. Okay, control C. I'm just going to the second page. You have to paste here. Okay, these are the two equations which I have written on the last slide. I'm just taking equation number 1 and equation number 2. Okay, then what you do from equation number 2, you just find out, simplify this equation. Lx4 double dot, this is nothing but your g sine x3 plus x2 dot cos x3. Okay, once you have written this, then what you need to do, you just put this equation number 3 in equation number 1, okay, and you try to simplify it. Because why? Because just I want to, because you see equation number 1 first. Whenever equation number 1 is there, if there are two variables are there, one is x2, another one is x4. Okay, but if you generalize, okay, generalize to write equation number 1 in terms of x1 x2, okay, then what you need to do, wherever the x4 term is there, you have to eliminate this by uh, okay, in terms of x1 x2. Okay, because why, if you go back on the previous slide, you can see that because x and x10 is the first state vector. Okay, similarly theta and theta 4 is related to x3 and x4. Okay, but he has given that we have to linearize the model. How to linearize the model? You have to take one variable at a time. So what you need to do, first in equation number 1, what you need to do, wherever the x4 term is there, you have to just replace in terms of x1 x2. So here what is there, L x4 dot, from the second equation I have to find out what is L x4 dot, and this L x4 dot here, whatever, just give another color, L x4 dot, you have to replace this L x4 dot here and L x4 here. Okay, so what you need to do, you just write down here, I'm just writing down. So m plus m x2 dot minus m into, okay, this value you have to put in place of L x4 dot g sin x3 plus this one. Write down g sin x3 plus x2 dot cos x3. Okay, let me erase this. Okay, then another you have a cos x3 is multiplied. Okay, then m L x4 dot, this is x4 square. Okay, x4 square. Okay, then sin theta equal to f. Okay, after that what you need to do, you have to replace this x2 star, because I have to find out my state vectors x1 dot, x2 dot, x3 dot and x4 dot. So here let to find out x2 dot, this equal to f plus mg sin x3 minus ml x4 square sin x3 divided by m plus m minus m cos x3 square. Okay, this is one state vector you have find out in terms of x2 star. Okay, similarly what you need to do, you go to equation number 1 again. Okay, and you try to eliminate this x4 dot, because first case we eliminated x2 dot. Okay, then the second case you have to find out x4 dot. If you find out x4 dot in terms of x1 x2, then from second equation in place of this lx4 you have to find out x2 dot in terms of other parameters. Then what you need to do, I'm writing the next slide. Okay, so you just find out, you have to eliminate, what you need to eliminate, you need to eliminate now x2 dot. Okay, if you need to eliminate x2 dot, then you have to express x2 dot from equation number 2. Equation number 2 x2 dot you find out. Okay, this should be x2 dot equal to lx4 dot g sin x3 divided by, what is that value, lx3 g sin x3 divided by cos x3. Then this x2 dot again put back in equation number 1. If you put back in equation number 1, let me copy the equation number 1. Okay, control C, go back here. This is equation number 1. Okay, delete this part. You can erase it. Okay, now what you need to do, previously we eliminated yeah, previously, what is that, ml x4, this is x4. Okay, previously we eliminated x4 dot. Now in this equation we have to eliminate x2 dot. Okay, so you place this x2 dot here. Okay, then you write down the equations. Okay, so I can directly write, I'm directly writing, you solve by yourself, I'm just writing the answers here. G sine x3 minus ml x4 square sine x3 into cos x3. Okay, that should be divided by L times of m plus m sine square x3. Okay, so this is the x3 x1 dot x3 dot x4 dot and x4 dot. Once you find out all the four values, then what you need to do, in the one condition in the question he has given to you, what is the condition he has given to you? The condition he has given to that, at theta at the equilibrium position you have to linearize the variable. So what you need to do, how at the equilibrium position you have to linearize, then what you need to do, you just find out this how to linearize, that is discussed in the lectures. So let me give a blank slide. Okay, so what you need to do, you need to find out the derivative, partial derivative you have to do, dx2 dot divided by dx3. Okay, because x3 and x4 are now, you can see here, theta equal to 0. Theta equal to 0 means x3 equal to 0, and what is the other dot, theta dot equal to 0, theta dot equal to 0 means x4 equal to 0. So around these two position you have to linearize. Then what are the variables you got, you have to differentiate all these variables, x2 dot. Okay, what you got in the last variable, x2 dot and x4 dot. Okay, so now what you do, x2 dot partial derivative with respect to dx3, then x2 dot partial derivative, sorry, x4 dot. Okay, x4 dot partial derivative with respect to del x3. Similarly you have to find out another two partial derivative with respect to x4 and dx2 dot with respect to dx4. These four values you need to find out. Okay, and what is the condition, and every condition you have to put what, x3 equal to x4 equal to 0. Okay, x3 equal to x4 equal to 0, because at this equilibrium position you need to find it, x3 equal to x4 equal to 0. This is a critical question, but try to understand that any nonlinear system how to linearize it. Okay, okay, so previously you have find out the derivative x2 dot, this one is the equation of x2 dot. Okay, I'm writing it equation number, let's say some a, equation a, and here this is your equation b. Okay, so in equation b and equation a, first you put x3 0 and x4 0, then you need to do the partial derivative. Okay, so this is very simple. Okay, because x3 and x4 whenever it is 0, then you have to just differentiate with respect to x3. Okay, so this value dx2 star by dx3, if you check, okay, go to dx2 star divided by dx3, dx2 star, this is dx2 star divided by dx3. Whenever you put x3 and x4 equal to 0, x3 x4 0 means this value is going to 0, this value is going to 0, sine x3 is going to 0. So what is remaining, only that is sine x3, x3 is 0, sine 0 is 0. Okay, so what are the remaining thing is only, remaining is f by m. Okay, so like that you have to find out every term. Okay, like that you have to find out every term and put all the values. Okay, whatever the value of f is given, whatever the value of m is given, Like that, you need to calculate all the values. Once you calculate all the values, you can do by yourself. Then you need to compute. Okay, x1 star, x1 star equal to x2, always you know. X2 star equal to, you always know that x2 star equal to x3, x3 star equal to x4, we know. But what is x4 star? X4 star you just need to find out. Okay, then you create a 1 cross 1 matrix. Okay, so that is a simple way you can linearize any system. Okay, so the corresponding matrix will be something like Jodal canonical form. Okay, like 0 1 0 0 0 0 1 0 0 0 0 1, and let's say a b c d. Okay, like this form you have to represent. Okay, so what they have asked in the question, that they have asked that what is the whatever the matrix you got here, a matrix, so what is this values b? Okay, means corresponding to the third row and second column. Okay, third, sorry, fourth row and second column, what is that element? Fourth row and second column dimension, what is that element? That element you need to find out. Like that, they have asked some question, you can find it out. Okay, okay, this is a little bit a tricky question, that how to linearize a system. What you need to do, you have to just find out a non-linear system is there, you have to eliminate and you have to find out the linearized system, because he is asking us to find out the linear system about the linear point. Okay, okay. Let us come back to the next question. Okay, okay, this is a very simple question, I think. Okay, consider the LDI system, whatever the system is given to you, you know that x star equal to ax plus bu. Okay, now A is given to you. Okay, this is the A matrix is given to you. And the question is that the minimum number of non-zero elements. Okay, so B matrix he has not given to you. B matrix you have to find out. Okay, this is a 1 cross 3 matrix. Oh, sorry, 3 cross 1 matrix. Okay, then the minimum number of non-zero elements in the matrix B such that the above system is controllable. Okay, so for controllable, what you need to do, you first find out the controllable matrix B, AB, and A square B. Okay, so you know that you make the determinant not equal to 0. Okay, so first of all, assume that B equal to A, B, and C. Okay, you assume like that B equal to A, B, C. Then what you need to find out, you write down this, complete this matrix B equal to A, B, C. Then what is A and B? A equal to 0, A1, 0. Multiply here. Okay, just to multiply A into B. This is A, B is A, B, C. You can write down here like that. Multiply this. 0 into A is 0. A1 into B is coming. 0 into C is 0. So what is the A1 into B? The first element is A1B. Similarly, the second element you multiply. 0, have to multiply this, have to multiply this. So this is 0. A2 into C. This is A2 into C plus A2 into C. Next, what is the next element? Sorry, A to C is not here. This will be A to C. And what is the next element is 0. Like that. After find out AB, okay, then you find out A square B. Okay, A square B is nothing but AB into A. Okay, A into AB. A is this one. AB is, I can write down A1B, A2C, and 0. Now we multiply 0 into A1B 0, A1 A2C. Okay, so this will be A1 A2C. Next, this will be 0 into 0 0, so 0 0 A2. This will be again 0 into this, 0 into this, and then A2 into 0 is 0. So this term is 0. Then this is also 0. So these are the three values now you find out. After you find out these three values, you find out the determinant of the matrix. So now what is the determinant of the matrix? this column is 0, this column is 0, so only C is remaining. So you can write the determinant equal to C into this is 3 cross 1. Okay, okay. So C into how much? A1B minus A1 A2 C into A2C. So everywhere A1BC minus A1A2C A2C. Yeah, I don't know if I am doing wrong or right. You just check it out. Okay, it's the determinant of the matrix. So now you just check me the minimum number of non-zero elements in the matrix B so that the above system is controllable. To controllable, this matrix should not be equal to 0. Okay, this determinant should not be equal to 0. Okay, then you have to see that if one element is 0, let's say if one element is 0 from B matrix, let's say B equal to 0. If B equal to 0, then this term is 0, but this term is non-zero. Okay, let's say if A equal to 0. If A equal to 0, then there is no effect. Okay, but B equal to 0, this term again means I think for the minimum number of non-zero elements should be how much? I think all are satisfying here. You can see if only C equal to 0. If you put C equal to 0, okay, then only the determinant is coming 0 because C is present in both the sides. Okay, so it means if one element like C is 0, then you are going to be non-controllable state. So the answer, the minimum number of non-elements should be equal to 1. Okay, and other thing, it doesn't matter B and C, only one element if it's 0, then the is going to be non-controllable. Okay, so let us go to the next question.
Sir, if it is not equal to 0, that means rank is
Yeah, you can
2,
find out in terms of rank, determinant not equal to 0 means
rank
rank.
is 2.
Rank you can this is the matrix na.
Yes,
Rank
sir.
of the system you have to just make into some properties. If the determinant not equal to 0 means rank should be equal to 3.
Okay, okay.
Okay, because here you suppose like that you can say a matrix like that 1 0 0 2 1 2 and this column is 0. Then you can say that once row is 0 means the determinant is now 2, just starting from 2, because one row is always 0. So determinant it depends on these two. Okay. So the
Okay.
minimum now the rank was starting from 2, maybe 2 or doesn't 2. It depends on all the matrices, all the dimension of 2 plus 2. You have to check and see the determinant equal to 0 or not. If at least one is 0, then again the rank will be reduced to 1. Okay. In terms of rank also you can do, but this is question is not to find out the determinant and check that which value is satisfying or not. So now like that here you can see this is another type of question. The system is observable. The system is observable for what? For what values of A1, A2, A3? This is the four system is giving. How to do? You know that one thing that discussed in the lecture is Jordan canonical form. What is Jordan canonical form? 0 0 0, sorry, 0 1 0 0 0 1, let's say ABC. This is called a very good Jordan canonical form. Okay, now if this matrix is A, if you do the transpose of that matrix like 0 1 0, then 0 0 1 A B C. Okay, this is called the Jordan canonical form. Okay, uh, this is called A and this is a A transpose. Now by looking at the question, if the system is observable for, if you're very smart, if you're uh, not okay, don't want to waste your time, you are smart little bit, you check that whether this A matrix that is I have written, which is coming under A or A star, this is coming under A star. because A transpose. This is related to A transpose. If it is written in terms of A transpose, if a matrix can be represented either in Jordan canonical form, then the matrix is controllable as well as observable. Okay, then you can say that this is controllable by default, and if you take the transpose of that system, that is always observable. Okay, so now we can see that the A matrix is written in terms of your A transpose. So for whatever the values of okay, put A1, A2, A3, the system is always observable because it is represented in Jodal canonical form. Okay, so don't waste your time. You just see whether it is represented in Jodal canonical form or not. Okay, so otherwise, what you need to do, you have to find out then CA square, okay, and check all the values of A1, A2, A3 combinations, okay. Because you have options, okay. You put the options and check from the matrix determinant itself. But why would waste time? You just need to know the properties of, okay, observable and controllability. Observability means you have to check that it is A transport, okay, it is in the form. Okay, there are two, three forms are there like Jordan canonical forms. Okay, then Ackermann's formula is there. So by the time you can observe and you can see. Okay, don't waste your time. So this is question related. I just want to see that whether you need to identify or not. Okay, coming back to the next question. Let me give this question to you. Consider the following system, but you can see here A, this vector A is asking something about observable, but A is not in Jordan canonical form. Okay, you can check it because it is not 0 0 1 0 0 1 and A B C transpose. This is not the transpose of this.
010 na sir.
Yeah, 0. This will be 0 1 0. Sorry, like that you understand. Okay, it's just a printing mistake of myself. But you try to understand that this A is not in the format. Okay, then what do you need to do? You have to solve the question. There is no other options for you. So you need to find out CA, and CA square. Okay. So what is C is given to you? C is given to you C1, C2, and C3. What is CA? C is C1, C2, C3. Okay. You have to multiply with this matrix 7, 0, 0, 0, 1, 0, 0, 0, 4. Now you do the matrix multiplication. Okay. This is transpose. Sorry. This is that. What is that? C transpose A transpose. Okay. If you always this matrix is like that, this you have to make the transpose. It will be how much this will be? C1, C2, and C3. 3 cross 1. This is multiply. How did you multiply it? How to multiply? Because this is a 1 cross 3 matrix. This is a 3 cross 3 matrix. So what you need to go? You got a 1 cross 3 matrix. Okay. So do that. You have to multiply like that. C1, C2, C3 is in each element. Okay. So first of all, 7C1. Back remaining 2 is 0. So be 7C1. Next, this one is multiplied to here. So C2. Then again 4C3. Okay, like that. Then what you need to do? CA square. Okay, means it will be something like that. 7C1, C2, and 4C3. Multiply this now. Find out 7C1 into 749C1. Remaining two element is 0. This will be again C2. Then this will be 4 into 4, 16C3. Okay, this is the complete matrix you got now. Okay, just do the multiplication. Now you can see that C1, C2, C3 and C1, C2, C3, C1, C2, C3. What is the rank of this matrix? How many columns are identical? Two columns are identical. Okay, rank of the system is 1. So you can, by looking at the system, I can say that the determinant equal to 0. The determinant equal to 0 means the system is non-observable. But he wants the system to be observable. Then what do you need to do? Because you find out the determinant. Okay, you find out the determinant. Okay. Then the determinant you see that C1, C2 and C3 all should not be equal to 0. These properties will be satisfied. If one element will go to 0, then the system is going to be observable. Okay. This is just need to find out the determinant of the system. Okay. Because by looking at the system, I can see the rank of the system equal to 1 because C1, 7, C1, they are multiplier, C2, C2, C3, C4, just a factor is a multiplier. Okay. Now coming back to the next question. Yeah, this question is little bit tricky by using Ackermann's formula. Have you gone through Ackermann's formula how to solve this type of question? Okay, let me solve it. We can solve it by using MATLAB also, but MATLAB is not allowed, okay, in the examinations. Okay, so see how to do. So whenever this type of system is coming into your screen, what you need to do, you see that using Ackermann's formula, okay, you need to find out because what is the system? Because you know that whenever a system or plant is given to you, you just know that there are something. Let's say I'm just this is the plant. What is that? There is some part of the system is controllable. There is some part of the system is non-controllable. Some part means some state variables. Let's say these are x2, x3, and these are the three state variables because it's a 3 cross 3 matrix. Okay. So out of this x1, x2, x3, okay, the three dimensions. Okay. So what you do? Some part of these vectors, state vector, let's say I'm putting x1 here. X1 is controllable, but x2 and x3 are non-controllable because some state vectors are controllable, some state vectors are non-controllable. Then what you need to do? You have to design a system such that, okay, you have to find a state feedback vector because if you find a state feedback vector such that you have to place all the closed loop poles to the left hand side of S plane. Okay, so suppose one pole is here at -3, one pole is here. Okay, I'm just giving a two-dimension system. Let's see, x and y are there. Okay, so there are two state vectors, let x1 and x2. So but x1, let's say controllable, x2 is not controllable. Then what you need to do, you can vary this x1, okay, to in this total minus x to x, okay, because it is controllable. So you can vary the state vector from minus infinity to plus infinity in this direction. Okay, but here x2 is non-controllable, so you cannot vary it. Okay, it does not depend on because it's uncontrollable. The state vector you cannot, it's not in your hand, you cannot controllable. Okay, but you have to design. Suppose I want to, suppose one pole is here. If a system is controllable, okay, let's say this pole is at 3, but you know that x1 is controllable. You can vary the some factor you have to multiply here so that this 3 can be go to the left hand side to make the system stable. Okay, so that thing is done by the Ackermann's formula. Okay, so what you know, suppose you want to place the closed loop poles at -5, -3 and -1. Okay, you have to place at -5, You have to place at -1 and you have to place minus, because you want the system to be stable. Then what you need to find out is state vector. It's nothing but a feedback, you can say. What is the thing I multiplied to the state vector? Minus k into x. Now x is a state vector. So what is this value k? You have to multiply such that a pole which is placed on the right hand side can go to the left hand side to make the system stable, because like that you have to think. Okay. So in the there are 2-3 steps to solve such kind of question. You can solve it. Okay. The first step, what you need to do, first step you need to find out. Okay. First step you need to find out a matrix. I am just denoting like that. Okay, let me erase it. So let the pole is located at s1 equal to -5, s2 equal to -3, and s3 equal to -1. These are the three poles. First of all, you have to form a characteristic equation, because for a plant we are the things we require some plant is numerator by denominator. Okay, this is the plant is represented. So this denominator part we are interested, because the denominator part gives the closed loop characteristic equation. So first find out the ds. The ds is nothing but, okay, just give me a variable, like I'm saying, so denominator part, let's say I'm just representing 5s. Okay, this 5s is nothing but s plus 5 into s plus 3 into s plus 1 equal to 0. This is the characteristic equation you need to find out. So what is the thing you just multiply? So this will be a square plus 8s, 5 plus this 15, yeah, 5 plus, yes, this will be s plus 1 multiply equal to 0. Now simplify it, this little bit, s into square is s cube, first term, 8s into s plus 1, 9s square. Then how many, what is the coefficient of s? 15s. Okay, 15s plus 8s, 15s plus 8s is 23s plus 15, this is equal to 0. This is the 5s, this is the denominator part of your plant transfer function. Then what Ackerman is saying, that whatever the function you get here, in place of s you replace by a. What is a? A is this one. So you replace now, in terms of a you replace by a. So now the equation will be a cube plus 9a square plus 23a plus 15. Okay. Once you find out phi of a, actually now the point is that you need to find out this phi of a. You know that, but see, this question if comes in the examination of NPTEL, it will kill your time if you cannot use the scientific calculator properly. Sometimes it is coming because they want to test your ability to use the scientific calculator. If this value a is given, okay, in the scientific calculator you find out aq, okay, and in the calculator, what is we are using scientific calculator, if you feed it a value and if you write the expression of this one, it will give you the value of phi a. Okay, try to do that. Okay, so the point of discussing this question is that you by yourself, okay, if a matrix is given some 3 cross 3 matrix, you need to find out what is the value of aq plus 9a square plus 23a plus 15. Okay, you have to check in calculator. This MATLAB I can do in 1 second, but in the calculator you should have to put the value so that you can get the correct answer. Okay, that is important. Otherwise, what you need to, you have to multiply a into a, then a square into a cube, then a into a square. So it will kill your time. Okay, it will take solve this question 10-15 minutes. Okay, so that thing you should be smart how to solve this question. So let's give me a blank paper. Okay, okay, okay. Let me write here. Okay, let's go to the MATLAB. I'll show you how to calculate this. Yeah, but I also don't know the answer. I have to calculate it out from MATLAB. Okay, so what is A vector you have to define here? A equals to, okay, the vector form you write down. Okay, what is the A vector? Is this MATLAB screen visible? Can anyone please comment it whether it is visible or not? Okay, this is the A matrix I have written. Is this everyone is there? Okay. Okay, once you write down the A matrix, okay, then you need to write the expression. What is that expression? Let's say I'm defining another variable z. Z equal to AQ. Okay, you write down AQ plus 9a square, na? Yeah, should be 9 into a square, 9a square, then 23a plus, write down 23 into a plus 15 plus 15, 23a plus 15. Once you write down here, you can write down what is the Z matrix, run it, save it somewhere. Choose the folder, compute it, what is the value of it. Now you can see A is this one, okay. What is Z? Z is this one, okay. So now once you do that, you'll got a matrix like that. Z equal to 52, 39, 59, 103, 52, 39, 63, 103, 52. So once you find out this matrix Z, go back to the slide. Okay. What you need to find out? You need to find out this matrix K equal to K1, K2, K3. So for that, there is a simple formula is there. You need to find out. Okay. So what is that formula? K is nothing but it is discussed in the lectures. You can go to and see 001 into C inverse phi of A. Okay. This phi of A is nothing but your Z. Okay. C matrix. Okay. What is the C matrix is given to you? What is that value? C means this is phi C, not C. Sorry. You need to find out. You need to find out this phi C. Phi C inverse. What is phi? Phi C nothing but your B into A, B and A square B. Okay. You have to find out this phi C and take the inverse of that, multiply out this and multiply out 001. You'll get the answer. Okay, it's a lengthy procedure, but same thing if I want to do in MATLAB, it will be very easy for me because MATLAB there is a predefined function that is Ackermann's. Okay, so suppose I want to B matrix I need to define. Okay, let me define B matrix. B equal to how much? B has given 101. Okay, so 1 0 1 101, right? Yeah, B matrix is defined. Now what you need to do, you have to find out the K matrix. K equal to, how to find out, this is a function is there actor. Okay, ACKER. Once you write down here, then you need to put some curly bracket. In the curly bracket you have to pass the arguments. What are the arguments? You have a matrix. Okay, you have to put a comma, then you have a B matrix, then you have to put the pole location. So what are the pole locations now? The pole location, that should be the argument like that. The pole locations, you can see matrix will be -5, -3, -1. Write down here -5, -3, -1. Okay, once you do this, run the system, you can see the K matrix is now given 8, 18 and 4. So 8, 18 and 4 is the answer. Okay, so 8, 18, 4 is your answer. So here K1, K2, K3 is nothing but 8, 18 and 4. Write down here 8, 18 and 4. Okay, these are the three values. Okay, this is one type of question that I don't think it will come in the examinations because it will take a lot of time to do. Okay, now coming back to the next question. Okay, so this is the question which is related to the previous one. Okay, so now what is the question is given to you? This question number 10, last question of the today. So consider the system x star equal to ax plus bu. A and b are given to you. Now use a similarity transformation, convert the system into canonical form denoted by x star equal to ax plus bu. Okay, using a similarity transformation function. How to do this question? How there is a non-canonical form, how to convert into a canonical form? That is the question to you. There is a non-canonical form, how to convert into a canonical form? Use a similarity transformation. Similarity transformation means there is some decomposition have you read. I have this is discussed in the lecture. Okay, you need to find out for the matrix that is given to you. You need to find out how many linearly independent vectors are there. Linearly independent vector. Okay, because this is a 3 cross 3 matrix. From the 3 cross 3 matrix you need to find out the linearly independent vector. So that vector, once you find out that vector, that is given by P matrix. Okay, once you know that, then you have to apply the linear transformation P inverse AP. After you do P inverse AP, this P inverse AP is converted into this canonical form. Okay, so for this 101, you have to first find out the eigenvalues, okay, of this matrix A, the first step. Second step, you need to find out the eigenvectors, okay, corresponding to each eigenvalue, okay, and this, from there you have to form a matrix P. These are called the linearly independent vectors corresponding to each eigenvalue. Okay, whatever the eigenvectors you got, you write down here. Okay, These are column vectors. Then you have to find out P inverse AP. Then that will transfers into a canonical form that is called your Jordan canonical form. And there you have to compare the coefficient A1, A2, A3. Okay, and write down the answers here. This part is this part is very important because this type of question you can expect that what is the eigenvalues, how to find out the linear independent vectors. Okay, any other questions there? Yeah, it's similar questions. Still hitting it. Okay, so I thought of I have just stopped here. I just have some meeting. I just need to go. But one thing you just remember that uh, this is week two over. So I think your exam is on next week. Be prepared well. Okay. So better what you need to do before going to the examination. Little bit you need to uh, uh, familiar with the scientific calculators. Okay. So that scientific calculator usage will save your time. And second thing, what you need to do, that the questions are not that tough. Okay, 70-80% question will be okay. They are mostly related to the assignments. Okay, if you do the assignments of week 12, every assignments, okay, you see the answers. Okay, which answers are provided to you. Okay, and what are the uh, videos that is uploaded? You see what the professor is going to solve the questions. If you solve only this much, then of 80% of your answer you can attend, okay, in the stipulated time. There are always 10-20% questions, okay, which are beyond of the hand. You can have to think, you have to apply your mind, you have a time, you can solve it. If you don't have time, you can skip it and be relaxed because it is not that of everything's cup of tea. So uh, don't worry. All the best for all of you, all the exams, okay, and well, that's it from
Thank
my
you very
side.
much, sir.
Okay,
Thank you very much.
so thank you for attending this course. Okay, uh, well, okay, thank you. All the best, guys. I'm stopping here. If you have any doubt, you can post in the query.